All right. So yesterday in class, we talked about money and exponential functions. So the value of a car is 31,000. It drops by 8% every year. That's the same thing. That's equivalent to keeping 92% of that car's value year after year. And so that's how you would get this formula. Dropping 8% is the same thing as keeping 92%. The half-life, losing 50% is the same thing as keeping 50%. So that's why our base is 0.5. And in general, the general formula for a half-life problem is the initial amount times 0.5 raised to the x divided by the half-life, however long the half-life is. The renal population is growing by 7.1%. So our base is 107.1%. That's 100% of the population plus 7.1% more. And so that's how we get this base, 1.071. And that is the base is bigger than 1, so it's an exponential growth. Now we need to apply this idea to investing and paying off debt. So you've seen these functions before. This simple interest, this is linear, not exponential. So this really won't be tested on Monday, or the test is Friday and Monday. The Monday will be the calculator part. Compound interest is. So the A is the future amount. That's how much money you will get after so many years of investing. P is the principal. That's how much you invest originally. R is the annual rate. And K is how often it gets compounded. So for example, if R is 3% and it gets compounded monthly, so that would be 12. So that means every month your money is growing, but it's not growing by 3% because that's the annual rate. So you have to take the annual rate and divide it by how many times a year is growing, in this case 12. So you're only getting 1/12 of that annual rate. And so when it happens 12 times, then you get the 3% as promised, which is the annual rate. If it gets compounded weekly, then you just have to determine, well, how many weeks are there in a year? And there are 52 weeks in a year. So you're not going to get 3% every week of every year. You're going to get 1/52nd of that. So 3% divided by 52, that's how much you're getting every week. And then after 52 weeks go by, then you get that accounts for 3% for the entire year. So that explains this. That's your annual rate is being parsed out evenly, depending on how many times you get compounded. And then the exponent represents how many times you get compounded. It is K times T. So if you're getting compounded weekly for 3 years, so let's do a different number. How about 2 years? So for 2 years, every single week, that's 104 times. 2 years for every single week, that's 104 times in total. So that's why the exponent would be 104. You're getting that interest 104 times throughout the entire investment. And then if you get compounded just continuously, so 1 plus R over like an infinite amount of times per year, which seems kind of like a silly idea. Like, let's say every second of every year, so many times a year, that approaches this equation where E is the irrational number E, 2.71, and it goes on and on, raised to the annual rate times time. So that is what that's how you should think of what students call APERT, is when it's just like this function, except you're getting compounded continuously. So quick example, you want to find the accumulated amount for all of these. and the T is 7 years. The annual rate is 3.5%, so that's 0.035. And $400 was invested. So for the simple interest, remember the simple interest is the initial investment times this. So you put this in your calculator, $400 for the original investment, 1 plus the rate times 7, and you get 498. What if it's getting compounded annually? So $400 times 1 plus the rate, 0.035. Remember, divided by how many times per year. So if it's getting compounded annually, then that's just once per year, raised to the k times t. So raised to the 1 times 7. And you put that in your calculator, press enter, you get $508.91. If it's compounded quarterly, so again, following the formula, the principal times 1 plus the rate divided by how often it's getting compounded, raised to the k times t. So 400 is the principal, 1 plus the rate. Quarterly means, divide the year into 4 equal quarters. So 4 times a year, raised to the 4 times 7. Put that in your calculator, press enter, and we get $510.50. Compounded continuously. So 400, rate of 3.5%, not 4 times a year, not 100 times a year, but an infinite amount of times per year. So you really want to put this in your calculator, but that approaches this function. 400 times the number e raised to the rate times time. You put that in your calculator and we get $511.05. And just I want to point out, the more often you get compounded, of course, the better it is. But look at the difference between getting compounded 4 times a year versus literally all the time. Like every second throughout the whole year for 7 years versus just 4 times a year. It's not that much of a difference. It's only a 65-cent difference. So it's not, so we have to be careful with what gets sold to us when we're investing. So, and then on to something that is brand new, something called annuities. And an annuity is when you keep putting money into the accounts. That is the key characteristic. If you keep putting money into the account, that is an annuity. And we're going to keep it simple by just putting in the same amount of money over and over again. So it's practically a guarantee you will use an annuity at least once in your life. There are 2 types. There's one type, which is the future value. These equations will be given to you, so I'm not worried about you memorizing these equations. So don't worry about memorizing this. The future value and something called the present value. It all depends on when you have the money. The future value is usually a good thing. Like you want to save for something and it costs a lot of money. Like let's say you want to buy a boat and you want to spend $20,000 on this boat. So you keep on saving a little bit of money. You keep on putting money into an account. R is how much you keep on putting in. This might be called the payment. Everything else means the same thing. R is the annual rate. K is how often it gets compounded. It also represents how often you're putting the money in. And T represents for how long you are putting the money in for. These first 2 equations are just another way to express it, and I don't want to confuse you, so we just ignore them. So the future value, you keep on putting money in to save up for something that costs a lot. Like maybe your parents are saving for your college education. So when you were born, maybe they put in $50 a week or something. And then when you turn 18, you get this big chunk of money. That's an annuity. Or what's most definitely going to happen, a very, very likely chance of happening when you get your career, at some point you're going to retire. So you put money either into a pension or to a 401k or some sort of investment, an IRA, which is an individual retirement account, something where you keep on putting a little bit of your paycheck into this account. And by the time you retire, you have this huge amount of money that you can live off of. That huge amount of money is the future value of an annuity. But it can also go in reverse. What if you need the money right now? What if you need to buy a house right now and the house costs $200,000? You don't have $200,000. There's no one I know that has $200,000. So you go to the bank and you borrow money, and the bank gives you $200,000 right there, and you buy the house, and now you have to pay off the debt. So R is your payments. It's still how much money you're putting into the account, but you're putting money into the account to kill off the debt, to pay off the debt. Let's practice. So you're investing $120 each week into a fund earning 2% for the next 5 years. How much will you have after 5 years? This is a good thing. We're finding the future value. So the future value of an annuity is the payment times this big fraction, 1 minus 1 plus the annual rate over how often you put it in. Oopsie, nope, I'm doing the wrong one. 1 plus the annual rate divided by how often you put it in, raised to the k times t minus 1. All that is being divided by r divided by k. So R is how much you're putting in. You are putting in $120. 1 plus the rate, which is 2%, so 0.02, divided by k. So that's how often you're putting money in. We're putting money in every week. So there's 52 weeks in a year. And 52 raised to the 52 times 5, 52 times t minus 1 all over 0.02 divided by 52. We have to put this into our calculator very, very carefully. This will take some practice for sure. So I've got 120. We'll do green. 120 times . So what you see here, there are no variables here. This is all just a bunch of numbers multiplied, added together. So we could do this all in one shot. So you have 120 times what? Times this big fraction. So we're going to put parentheses around, we need parentheses around the numerator and around the denominator. So I have parentheses for the red one on the top, and then right away parentheses again for that 1 plus 0.02 divided by 52. I close the parentheses. So now I'm right here, guys. I just closed that parentheses, and I need to raise that number to the 52 times 5. So raise it. I need parentheses again, unfortunately, to the 52 times 5. And then I minus 1, and then I close the parentheses. I just closed that parenthesis right there. And now what's next? You have to divide by parentheses again, 0.02 divided by 52. Whew. And what do I discover? That after 5 years of putting all that money in, I will end up with $32,000 $806.70. If I put in $120 each week into this fund, earning 2%. About this one, you just bought a car. So you need money to buy a car. So you must have borrowed money. So you are finding the present value. And the present value is how much money you pay per month or per week times 1 minus this. You don't have any money. You had to borrow. So the dealership told you that, don't worry, son, just give me $410 every month for the next 5 years. So 1 minus 1 plus, this is a terrible, terrible, terrible interest rate. And that annual rate is being divided up 12 times a year, monthly, raised to the negative 12 times 5 over this. So again, these are just a bunch of numbers being multiplied, divided, and added. So I can do this all in one shot. So I've got 410 times 1 minus 1 plus 0.155 over 12 raised to the negative 12 times 5, which is negative 60. 155 over 12. So 410 times, now I need parentheses. I'm multiplying by a big fraction, and that fraction has a numerator and a denominator. So they must be grouped together. So 410 times parentheses, 1 minus parentheses again. So I just typed in that parentheses. 1 plus 0.155 divided by 12. And that parentheses, so I just typed in that parentheses, raised to the negative 60. Close the parentheses, so I just did that red one, divided by parentheses again. So I just opened up that one, 0.155 divided by 12, close parentheses, just did that, press enter. So you give the dealership $410 every month for 5 years. The present value is $17,045.56. That means that you went to the dealership, you found a car that you fell in love with, and it cost $17,000.45. So you borrowed all of that, and you're going to pay back the dealer $410 every month for the next 5 years. Unfortunately, what that means is that when you pay back $410 every month for 5 years, you are giving that dealer $24,600 for something, and you only borrowed $17,000, but you see you're paying almost $25,000. And all the difference between $17,000 and $25,000, that's interest. And the dealership keeps that interest. And that's a huge part of their business. That's the entirety of a bank's business. They only work on interest. And that's how they get their money. So be careful and be wise when you have money.